And it seems like we're live now. Hello and welcome to Fluence Community Call number 26. It's very nice to see everyone here. Let's wait a couple minutes for everyone to join. Kevin, no, they don't happen weekly, they happen monthly. So while we are waiting for the people to join, please send some pluses in the chat that you hear me well. Thank you, Ivan. Thank you, Kevin. Thank you, Evgeny. Morgan, thank you. So let's wait another minute and start. We have 15 people on the call already. Okay, so let's start from our agenda. So what we'll have today. So first of all, we'll have a quick check-in. Then it will be followed by a roadmap update by Evgeny Ponomaryov. He's co-founder of Fluence. Then we'll have engineering updates. I'll present them. My name is Fedor Kurbatov. I'm engineering manager, and inside those engineering updates, we'll have a dedicated demo on Fluence.js client from Akim, our lead JavaScript developer. Then Nadia will give us an update on the upcoming events. We have 2 major events ahead of us that will be held in Istanbul, and after that we'll have some Q&A sessions, maybe some questions from the community, and in the end we'll have the checkout sessions, and we will hand out POAPs for those who will stay with us till the end of this community call. Okay, so I think we are waiting for Evgeny to join us. Start with the roadmap update.
Hello.
Hey, hi. Let me just stop screen sharing so you could continue.
I can start screen sharing. Okay. Hold on. So I'm the first, right? Yeah, so we thought it's gonna be useful if I do this presentation again, because last call connection was not great, and it seems like no one could hear me. So it's pretty short. Just wanna basically give some general update on where Fluence goes and our overall understanding of the timeline and features, and so on. So like we think of Fluence as a kind of several big components, and like overall Fluence, okay, like we hear building serverless decentralized computing platform, right? So, and we separated it into several big things. One thing is developer platform, so it's developer features, toolset, and everything so developers can build and deploy applications. Second thing is compute marketplace, which means that compute providers, their pricing, their offers, deals that they make on chain with developers, all the payments and rewards. And basically, when developers deploy applications, they deploy on these providers via marketplace. Then Fluence DAO that manages all protocol, and then some potential vertical products, use case driven products built on top of developer platform and marketplace. So in terms of developer platform, what we target is serverless, like Lambda basically experience. And we have this mapping of traditional serverless components to toolset or like components that we have in Fluence. So we can think like it's not one-to-one clear mapping, but it's close conceptually. So in terms of functions, we have Marine that runs WASMs. So we have WASMs like services that contain of multiple WASMs as a sort of function analogy. For step functionality, we have Aqua, which you can use to create basically scripts with variety of function calls that express some sort of workflow, how this function calls should be called, on which peers and in which order, and with like more complex behavior. Then for calling function via HTTP, we have this intention to have either centralized HTTP gateway provided by Fluence Labs, or like multiple gateways provided by different companies, or allow developers to self-host gateways. So like you deploy sort of for your project, you deploy your own instance of the gateway, and then your functions would be, you can basically integrate your Fluence functions to external world, to some webhooks or any other Web2 tools via HTTP. As an analogy to cron jobs, like to call functions by time, we have spells. It's a little bit kind of different thing, but it's about executing Fluence functions based on like regularly based on time, basically. In terms of failover, like fault tolerance, we have intention to build in, like we have subnets, and subnet is basically replicated deployment of functions. So whenever you deploy a function, you deploy it on the subnet, and this way you will have fault tolerance, so you'll be able to switch from one function instance to another if like the first provider or server goes down, for example. And this would be done via Aqua failover algos, which are at the moment not yet implemented. On payments, we have the whole like payment model as a part of Compute Marketplace based on deals between developers and providers, and proofs of several types of proofs. I'll talk about it later. And then we have CLI, which allows to developers and also providers to access Fluence Network and all of this. So we are not talking much about yet about automatic scaling or any other languages or runtime support beside WASM. We're not talking much about too much data integrations. We only talk about that functions can access some data, like databases or data storage, or the web via HTTP via curl, or use IPFS. So like HTTP and IPFS are two basically ways to integrate your functions with external data. So yeah, I have slide on Compute Marketplace. Okay, so Compute Marketplace is the on-chain thing. So there are on-chain representation of providers. They can make offers with pricing. They can say which data integrations they support. Again, for now, it's limited to curl and IPFS. They can make deals with customers when customers want to deploy applications, and they receive payments in stablecoins. So the payment by default on Fluence right now is stablecoins. In the future, should be ideally an ERC20 token. And also, providers can earn rewards for providing capacity. So even if their resources not yet fully loaded via customer applications, they should be able to earn tokens by or earn rewards by proving that their servers, so their capacity is connected to a network. Yeah, so the marketplace looks like that. There is a on-chain representation of provider offers, and off-chain all the like real servers and Fluence peers like Noxus connected to this to the chain and see what they should do related to deals. There is several things related verifiability and incentives. So there is Fluence intends to have proofs of execution, which are two different types of proofs. There's the proofs for workflows in Aqua that will be done via probabilistic verification, on-chain verification of probably it's going to be ZK proofs of particles. So this is still in development, and we expect to ship it next year. Proof execution is related to WASM and Marine part. It's more complex because also it's a variety of different ways to prove the execution of particular WASM. By default, building like just ZK for WASM is too expensive. It's just economically doesn't make sense to do it for all the WASMs. So there is some ongoing research related to that. And there is a proof capacity, which is about how do providers prove that their servers are connected to a network, even if they're not yet doing customer jobs. So they basically provided these proofs, and I think I have a slide on it. So again, proof processing is about probabilistic on-chain validation of particles, or like ZK proofs of particles. And it's basically about nodes serving customer requests. Some of these requests based on some on-chain config is understood as a request that should be submitted on-chain for validation. Then the request submitted on-chain for validation, and then we can approximate who should earn what for the period of time that these requests represent. Like it's, for example, it's one request per million requests globally in the network. So we can reward all the providers for basically million requests based on submitting just one. And it happens constantly based on probabilistic parameters. Then proof capacity, it's a knowledge of proof of work based on RandomX algorithm plus some maybe ZK. Probably in the first release, it's not going to be based on ZK. It's just a native RandomX and its validation. Basically, providers commit some token stake and then they commit the time that they're gonna provide particular amount of capacity, and then they need to submit proofs based on some like epochs, like some amount of proofs per epoch. So, and while they're submitting, they get rewards for it. If they stop submitting, they may be slashed. So this is something that we expect to deliver in the initial mainnet setup. So the closest big milestone that we want to have here is planned for this winter, and it's basically the minimal developer platform features providing all that I mentioned, like Aquamarine, spells, subnets, and connection to data via serial and IPFS. It's a compute marketplace, which will be deployed to one of layer 2s. It's probably going to be application specific, like Fluent specific layer 2. We're still debating on final solution here, but this is important to make transactions low cost and to be able to also, like as a part of proof capacity, to validate proofs also cheaply. And this is and like obviously the DAO is a part of initial launch of all this. And we have like the huge lineup of features planned for after this milestone, both on developer platform and compute marketplace. So all kind of data integrations. We research towards other types of runtimes, other languages, like GPU support, and many other things. And on compute marketplace also, there is a lot of basically user experience features that we want to enable, like to allow customers even pay via fiat, to have like more trusted, less trusted providers, some sort of attestation and so on and so forth. So like enable liquid staking and all this. Yeah, I think that's the rough update. Again, we plan some big milestone for winter. A lot of work still needs to be done, but we are moving forward and we are very optimistic about it. Yeah, that's it from my side.
Evgeny, thank you very much for this update. Let's continue with the engineering updates. Okay. Okay, so first of all, we are going to roll out a huge update to our cross public testnet next week. So it will include two major things. So the first one is that we'll be updating Fluent CLI to support running local development environments with Fluent's local command. It's the latest functionality we've been developing, and it will be awesome for developers to try deploying to Fluent's network, to try to adapting their apps to Fluent's network without using some external nodes provided by Fluence, but they can use their own machines to do that. We also cover the improvements on Fluence deal logs command that was implemented by our network team. And after that, we will have a presentation from Akim Mamedov, who leads the development of Fluence.js clients on JS client updates and improvements. So the Fluence local set of commands. So we will be shipping this with our next update. It will allow to run local Docker Compose based Fluence network with blockchain for submitting deals with several Knox boxes. So and it will be used for local development. So you could run your apps without access to the internet and debug them, see the logs of the running containers, all with this nice commandlet. We also improved the Fluence deal logs command, and we have Alexey Proshutinsky on this call who can cover more on that.
I don't know what to cover more. I can show it like real time, but basically we just print all logs for installation of the workers by each worker, and it looks nice now.
Yep, so now you can verify that your deals were deployed successfully, that the workers, which is the part of your code that is deployed on the network, is deployed correctly. And now you can see the timings and the output looks nice. And now I pass the mic to Akim, who will cover the updates in Fluence.js client.
Hello, everyone. My name is Akim.
Your screen.
Okay, I can screen share. Nice. Yes, hello everyone. My name is Akim. I'm a JS lead developer. Today I want to tell you about JS client updates, what's new, what has been done. So let's start with some introduction. Kind of what is JS client basically. JS client is a tool for interacting with Fluence network. It's very easy to use because it allows you to just using plain JS dynamic languages to register services, call Aqua functions. So it's very simple comparing to Rust peer approach. JS client is used in Fluence CLI, for example, to run Aqua code. And another great example of JS client is FRPC substrate. It's our project of interacting with blockchain in decentralized way. So let's talk about features in JS client. For the past few months that I've been working on, the first feature is that JS client became platform agnostic. What does it mean? JS client have same interface in the Node.js and browser. It have same API there. It doesn't care where you run it. Also, it even supports direct import to HTML page via CDN, as you can look at this example. So it's very easy to use. And after, for example, after importing this script in your HTML page, you get a Fluence JS client object, which you can use. Okay. Next feature is a simplicity. Earlier, we had a ton of packages, JS client API, Node, Web. As you can see, we had a generic API package, then we had a package for each platform, and also we had network environment in a separate package, and it was very hard to maintain. For example, if you use JS Client on Node, you need to download API, Node, and network environment, 3 packages, and manage every of them independently. But now, today, you have to just use a simple import. So now life became much easier. Also, in the process, I updated docs and examples. Please feel free to check JS Client related docs at Fluence Dev. They've been updated, actualized, and tuned up. So I hope they're easier to use, easier to read and understand. Also, Fluence Labs examples has been reworked a lot. Many old examples were removed. Many other examples were rewritten completely. Also, I added a brand new example, which I want to share with you. Yes, so let's go ahead. Let's check out a new example in JS Client about how to resolve subnets using JS Client in your front-end project. Let me screen share.
It seems like screen sharing has stopped. Okay. So let's start with reading some Aqua code to understand the purpose of the example. So this is quick start example number 2, browser parallel computation. This example consists of 3 Aqua functions. We have already deployed deal with very simple service adder. This service just have one simple function, add one. To provided value, it adds 1 and returns the result. Also, we have function to resolve subnet from frontend. It is called from frontend project, gives you all workers from subnet and return result. Using resolved subnets, you build computation request from frontend. The computation request consists of worker ID, host ID, and value. Worker ID and host ID is a worker you want to run, and value is the argument to pass to adder service. So we have 3 methods of interacting with the adder service. First one called add one single method. It's that function accepts a single computation request, calculates the result on the specific worker and host ID, and gives back it to front end. Also, another function is add one sequential. It a bit more complicated. It works with multiple computation requests, and for each request, it executes every request one by one, and after all request has been executed sequentially, it gives the result to front end. And the third method is a parallel computation at the bottom. It's very similar to previous function, but it has 4 parse cycle instead of plain 4 cycle. It schedules every request in parallel, waiting for them to complete, joins the result, and gives the results to front end. Here's the
a single React component, which is import JS client with very simple import instruction here, just Fluence main API with few simple methods like connect, disconnect, and some other, and cross, the variable with cross relays. So let's look at the front end page. Here's the front end page. We can connect a relay. And here we have our peer ID, relay peer ID of local JS client peer. Relay peer ID is the peer ID which we use to connect. We have 3 numbers for parallel computation, or maybe sequential computation. These numbers are arguments to our functions. As stated before, we had 3 functions. Also, we have 3 buttons to each function accordingly. Now, for example, we can use first function. It just takes first number, computes it, and give you the result. Also, you can use compute sequential. It takes 3 numbers, build an array of computation request, passes it to peer, the remote peer, computes one by one, and gives you the result. And the last button is the compute parallel. It takes every result, forms a list from it, sends to peer, computes in parallel, and gives back to front-end page. And the order of the result is undetermined because there is a kind of race condition when executing with for-par instruction. So I hope that's all. Do you have any question?
Kim, thank you very much for this demo. I actually have a question. What JavaScript runtimes are you going to support? So as far as I understood right now, we support only Node.js and browser. Are there any plans to support more stuff?
Yes, currently we support only Node.js and browser. Probably we will support later Electron environment. Yes, there are the plans. So.
Okay. Any other questions for Kim? Okay. Then I guess we can proceed. So those updates for Fluence.js client and for Fluence CLI will be live on Cross Network next week. So right now we are finishing quality control procedures on these updates, and we are going to release it shortly. We will notify the community about that release via Telegram, Discord, and Twitter. So please stay tuned. And now I pass the mic to Nadia, who will tell us about our upcoming events.
Yeah, hi everyone. Should I share my screen?
Yeah.
Or you can make it. Okay, give me a second. All right, so from the past community call, we've participated in a couple more events in Las Vegas, which was like at the same time Filecoin event and ESPA accelerator for storage providers. So trying to get them better, presenting our project, and also visit the data center of Picnic. So yeah, that was pretty productive. Also, Bernard had a talk at All Things Open, also in USA, in South Carolina, presenting Fluence to Web2 developers. That was also very productive and nice. Yeah, we still don't have talks from and workshops from those events, but they will be published soon at our YouTube channel. So please follow us there, and you'll get more information soon. Yeah, and the next two stops is Istanbul. They're gonna be DevConnect and Lab Week, pretty huge community gathering, which happen like once a year. And we're gonna make our huge summit, which is like become really big. We thought it's gonna be a side event, a small side event, but it appears to be pretty big and nice. We have a lot of partners and we have a lot of talks. So in case you are in Istanbul participating in DevConnect, please join us on November 15. Yeah, I'll drop more information about our plans for Istanbul in Telegram group soon. Yeah, that's actually only Staking Summit and Decentralized RPC Summit, but we also will be at the whole Lab Week and all the Filecoin events. Yeah, so feel free to meet us there. And for December, we're planning our trip to India. And yeah, there's a lot of crypto events and Filecoin events as well. So I believe there are going to be more information about India events and the next community call. So stay tuned. I'm going to publish everything in Telegram and Discord. And yeah, pretty much all the talks from these events are on our YouTube channel. Yeah, that's it. We have POAPs for the participants of today's community call. So I'm going to spend like the next 5 minutes distributing them through the DMs. So yeah, let's get back to Q&A, right?
Yes, Nadia, thank you. So any questions so far? There is a question from Purity. Is Fluence open to explore more events in other parts of the world?
So probably yes. I think for the past year, we've been to Asia, we've been to US, we've been to Europe, pretty much everywhere. We haven't been to India. I think never been to India, so this is our plan for the next month. And yeah, it seems like we've covered almost all the globe. And for the next year, we don't really have the strong plan, but we probably will go to ETHDenver and Consensus again, and maybe something else, which is like, I don't know, not announced yet. Yeah.
Okay. Any other questions?
I think we're good.
Okay. Nadia, how we are with distributing the POAPs? We just by the chat.
Yeah, I think I'm done with our guests and not done yet with the team, but I think we can distribute it later within the team, so we can wrap up.
Okay, so then thank you everyone. Thank you for taking your time to be with us, and see you on the future community calls. Have a great day. Bye-bye.
Thanks, everyone. Bye.